Hello and welcome back. Good morning, good afternoon, and good evening to everybody around the world. Um, with us today is one of the co hosts of IA for AI. Jessica Talisman is an accomplished information architect with over 25 years of experience in building robust information systems that enhance user experiences, um, support business goals, and enable machine learning and other AI technologies to function more effectively. Her expertise spans enterprise architecture, knowledge management systems, digital libraries, taxonomies, ontologies, and knowledge graphs across various domains. To put things into perspective, she's been a key driver in developing 8 enterprise knowledge graphs. I mean, what more needs to be said there? Uh, Jessica, it's a pleasure to have you. And
Thank you.
would you, is there anything that you want to say about, you know, the event or any motivations?
Yeah. No, I'm very excited because, within the information architecture space, it's a pretty multidisciplinary, cross-disciplinary domain space. Information architects come from library and information sciences, human factors, and we also see folks from UI, UX in the space. So it's nice to bring everyone together. We have come up with sort of conceptually the idea of a full stack information architect versus a front end information architect and a back end information architect. And this is more about, bringing everyone together in this domain space because obviously it all connects. And it's instrumental for success in AI. And we're going to see a lot more of that coming to fruition and truth as, at base, we're looking at findability and fair data, which is findable, accessible, interoperable, and reusable. So thank you everyone for joining. Uh, my presentation information is really around intentional arrangement. Intentional arrangement is important, especially from my background as a librarian. I served as an academic librarian first in my career before moving into the corporate world. I've worked in many different domain spaces, but there's a unifying principle throughout, which is, dealing with data and making information and knowledge accessible, retrieval, and interoperable for all. I'm currently a senior information architect with Adobe, working on really interesting and complex problems in the content management space, both for information architecture alone, so the normal boring problems, and the more complex issues related to AI. So next slide. The idea of intentional arrangement comes from Robert Glushko's book, The Discipline of Organizing, which is a brilliant book about information architecture broadly and information science. So it's an interesting space because we're asking basically or begging the question of how we organize information. LLMs or AI are affecting every domain and industry, and there's one universal truth that binds them all. Initiating and deploying LLMs requires well-defined, structured data. To boot, also, LLMs benefit from data that is clean and curated. To narrow the scope, to represent the digital fingerprint of a domain or organization. So the cleaning and structuring of data is not for the faint of heart, as many of us know and have faced in our own organizations. Some of us are kicking at the door, hoping for an AI miracle where we can appropriate the task of building taxonomies or ontologies to LLMs to automate that, like we want to automate everything else with AI, which is a little bit of an awkward situation or proposition. So, intentional arrangement asks us to require a human in the loop to set our intention as we set our best effort forward towards defining and describing and organizing information and data within spaces, digital landscapes. The intention to choose how to represent and present ourselves to AI is possibly one of the most difficult questions, just like, one of the most difficult issues in software development is naming things. To be intentional is like various other mental states. It consists of two components. a content and an attitude towards this content. The content of an intention is the action plan, and the attitude involves a commitment to execution of this action. Intentions may share the same content with other mental states, like beliefs and desires, but the different or various mental states are distinguished from each other with attitude and commitment. The interesting thing about librarians is that librarians seek to bridge the gap between people and information and technology. This spans the physical and digital spaces in places such as governments, companies, academic institutions, and in local libraries. The idea is that information and knowledge is free to every citizen, and it's a free service. So we asked the question, what is information and library science? And this is important because it's the foundation for how we organize or curate information for thousands of years. So this is a painting of the Library of Alexandria. So next slide. Next slide. Thank you. It's a picture of Library of Alexandria and under attack by the Egyptians. And so why was it under attack? Because libraries society, and destroying the intellectual hubs of the society is to conquer it. It's a type of spiritual conquest. So the Library of Alexandria was founded in Egypt by Alexander the Great in 283 BC. Alexandria is a cautionary tale of the dangers of creeping decline through the underfunding, low prioritization, and general disregard for the institutions that preserve and share knowledge, libraries and archives. Next slide. The Library of Alexandria, although destroyed in 283 BC, is still operating today, a manifestation of the original library. So it's obviously not the original library, but it has the focus now on digital collections. Built together with one of the best schools of library and information science in the region, the hum of its vast server farm has replaced the quiet concentration of the scholars who worked in the institution of the classical period. But even the newest, most advanced libraries need to be treasured and respected if the knowledge they contain is to survive. Next slide. Librarians and information scientists have been on the forefront of this movement of intentional arrangement. Just as cataloging in traditional libraries involves metadata and structuring of data, the same is true in the case of digital libraries. In cataloging web and digital resources, librarians are focused on structuring data to present the aboutness of a digital object and the relationship between those objects. Before the proliferation of semantic technologies, metadata was used to generate structured indexes to support keyword retrieval, where knowledge was implicit in structured textual information. Early digital libraries digitized the structures of card catalog systems, bringing the macroscopic and microscopic into view. It was the digitization of library systems that served as the foundation of structured information on the web. Next slide. Intentional arrangement does involve cognitive modeling, a core principle in semantic systems and underpinnings of AI. Cognitive models of information retrieval rest on the mix of areas such as cognitive science, human-computer interaction, information retrieval, and library science. So cognitive models describe the relationship between a person's cognitive model, so the humans, what we refer to as a mental model, of the information sought and the organization of this information. So cognitive architecture is about the structural properties of a modeling system. Cognitive modeling constrains a system to live within the boundaries of the cognitive architecture and also informs the system and humans of the limitations, gaps, and shortcomings of the system. So an example of this, or examples of this in real life, are weather forecasting models, earth simulator models, flight simulator models, molecular protein folding models, and neural network models. And these are examples of cognitive modeling and cognitive architecture. A cognitive model structures the aboutness of information. A librarian's cognitive model is founded upon the human and machine cognitive models. So the idea is to bridge the gap to make information accessible. Next slide. These exact technologies or techniques of cognitive modeling have been an essential part of the formation of the World Wide Web and the technology landscape of today. The HTTP and HTML protocols, which underlie the World Wide Web, took much of their inspiration from these concepts from information and library science. of documents, which represent entities, linked data, which connects these documents semantically, and a markup language, which allows you to specifically formalize machine readable structures for your documents. Some of the earliest big businesses built on the web also borrowed very heavily from well-established information and library science techniques. Yahoo can be thought of as an early online card catalog, rendering an index which organized the web content into hierarchy with ontological cross references. Google built a massive search empire on top of the concept of using the number of cross references to a page as an indicator of that page's reputation and relevancy. Counts of scholarly citations were used as marker of relevance in library science long before the web ever came about. Next slide. In 1994, two Stanford students started Yahoo, a manually constructed table of contents for websites. Other early search engines emerged, such as Lycos and WebCrawler, and began automatically indexing web pages, focusing on keyword-based techniques to rank search results. Around the same time, Google's Larry Page and Sergey Brin, funded under the NSF, or National Science Foundation supported digital library initiative project at Stanford, took an interest in the web as a collection, and that's key. They built upon the Yahoo Index work to invent web page ranking. Page ranking assumes the value of linking documents or pages on the web. Linked data provides a map to the sharing of information, grounding digital objects in a source of truth based on human classification of knowledge. Classification of knowledge, in this case, the human created links between web pages. So this is an intentional arrangement. Next slide. The original Google prototype crawled from page to page by following links. It compiled a standard text index and mapped out a vast family tree that reflected the web links among pages. It's an early knowledge graph. To calculate rankings from this family tree or taxonomy, Sergey and Larry developed the PageRank method. PageRank is the method of applying ranks to web pages. A page ranks highly if many other highly ranked web pages link to it. Those other pages ranking in turn depended on the page that linked to them. There was desire, there were beliefs, and the intentional arrangement of page ranking is in fact intentional arrangement. Next slide. Let's look at how the space has been evolving in the recent years. Today, the largest innovations in search engines and information retrieval on the web have been around generative AI techniques or large language models. LLMs are built using an artificial intelligence technique called deep learning, which employs multi-layer neural networks with layers of transformers. OpenAI's ChatGPT is the most well-known of these LLMs today. The GPT stands for Generative Pre-trained Transformer, and these models can be absolutely massive. The training data sets for the ChatGPT model are over 45 terabytes, probably more at this point in size, and the trained model has over 1.5 billion parameters, which you can think of as individual logic gates within the model. As you can imagine, giving these numbers, these models are quite expensive to train. In terms of compute power, money, and time, cost for a single training run can top $100 million. I wish 10 million. Next slide. Because of the huge cost to train an LLM, AI ML researchers working in the space have developed a technique called retrieval augmented generation, or RAG for short. RAG is a technique that allows you to supplement the data in the pre-trained model with other context data, which wasn't available when the foundational LLM was trained, or it might help to curate and direct an LLM to be specific to a domain space that's well defined. A good example of when this comes in handy is when you want to join your internal company's data sources like wikis, help pages, and internal knowledge graphs with the power of the LLM. Paying OpenAI for a custom trained model that includes the 45 terabytes of their standard data sources, as well as your corporate data assets, would be prohibitively expensive in most cases. With RAG, you can inject that same context at model prompting time. However, not all RAG results will be the same. The structure, quality, and consistency of the inputs can have a huge impact on your results. It's basically the garbage in, garbage out problem. In order to get the best results from LLMs and RAG, you need to have high quality and well curated data, ideally in the form of a knowledge graph. This can be seen as a type of intentional arrangement, post haste, but still intentional arrangement. Next slide. Most often attributed to humans and their relationships to physical environments and sensory feedback, embodied cognition is the subdomain of cognitive modeling in open dynamical systems. The idea of embodied cognition is shaped by the indicators and mediators within a system. The indicators carry information about the existence of an object in an information environment. How does this work in a machine-based system? Smells, tastes, physical pains, all feedback loops for humans. But for machines and AI, how does this work? Let's take the example of taxonomy. The hierarchy of a taxonomy are indicators that these information bits exist relative to other pieces of information. The mediator delivers information about the environment that the information lives in. Think of a mediator as a description of the environment, including language, translations, and agents within. A mediator may be described using a schema, an ontology, and knowledge graph. Retrieval augmented generation, or RAG, is a great example of a mediator in dynamic systems like AI. Simplified, for a librarian, these information objects exist as artifacts first and are assigned descriptions. The descriptions are modeled for the human cognitive model and the machine cognitive model. The goal is to make use of information acquired during the information gathering process and present the information in an organized and accurate fashion. That is, not leaving it to the AI gods to declare an oracle or rendition of intended output, but setting the intention before the output arrives. Next slide. And library science information retrieval is the end goal. Coined in 1952 as a facet of library science, information retrieval advances in libraries were beginning to expand into the digital realm, that is, beyond managing physical repositories of books. Vast improvements in cataloging and indexing presented new models to support human information retrieval processes in digital landscapes. Next slide. So finally, where does information architecture fit into this whole picture of AI, cognitive models, cognitive or embodied cognition, and RAG? Information architecture is really about describing aboutness. It is intentional arrangement to create descriptive arrangement, or what we may call semantic arrangement. We are experts in prioritizing the structure and meaning of objects and describing artifacts within a system. We create systems for organizing based upon methodologies that have been used for thousands of years in the library and information science domain. Classification schemes, such as taxonomies and ontologies, are used to describe things, including context and relationships between artifacts, and the co-location of these things to understand beyond the local instance. Librarians are always concerned with how the local affects the global. We want to make information accessible to all, including machines. Next slide. So a great example is if we look at the aboutness of an information artifact in the library and information science domain, and this is broad for information architecture, we can see each part that makes up the whole. So this is for a book, and the call number or location, author, title, subtitle, and so on are descriptions of instances of that artifact, in this case, a book. We know that the artifact has a who, what, when, where, and how. The why is left up to the user, which happens at the point in which the information is retrieved. That's part of information retrieval, is presenting more than one option for the user to choose from. It is up to the end user to determine the value of information and to integrate the information and to then convert it into knowledge. That is intentional. Next slide. To imbue knowledge, data must be structured in order to become information. Controlled vocabularies, taxonomies, thesauri, and ontologies represent stages or layers in structuring data and ways to deal with complexity. This sequence was codified as a methodology within the digitization of bibliographic records, which was the last slide we looked at. And for linking these records, this method provides successful and aimed, it has proved to be successful and aimed to support information retrieval and cognitive models to support all human behaviors in trying to find information. If machines and humans are able to discover and manage information successfully, then the data modeling methodology works. To be clear, librarians are not tasked with interpreting data or information. That would introduce bias. We only want to structure artifacts to help humans and machines find things as accurately and as quickly as possible. This modeling practice is known as intentional arrangement. Next slide. So how does this all work in the real world? In library science, this is known as authority control. Authority control grounds a digital object and establishes its existence. This could be a book, movie, song, article, or image. Part of authority control is to minimize the opportunity for misinformation. Authority control is used in ontologies to codify the meaning of a thing relative to other things in a vast sea of information. An ontology declares a book as a book and then extrapolates to define that the book is a paperback and a nonfiction work. In this vein, it is not unlike the data in your organization. We do not perceive of duplicates until we look for or discover them. It may not seem like a big deal to present a machine or people with individual data objects that are pretty much the same, but compound these occurrences in a system and you arrive at a findability problem. We try to find more information if the existing landscape cannot make sense of the data within. You should not think of your data in isolation to your organization. You should think of it as connected to the broader corpus of structured information or data in the world. Grounding concepts in truth and linking data to authority sources also helps to define said concepts. This is done using URI or URN to create permalinks. These URIs are foundational to robust knowledge graphs. Next slide. So I'll quickly go through an example about Cookie Monster. Some of you may have seen this before, but we'll look at this real world example. And as this being our subject, it's a well-loved fictional character. Some of you may know from Sesame Street called Cookie Monster. Next slide. So when we look at authority records and what constitutes an authority record and ontologically or creating a triple statement to represent, for example, Cookie Monster, they're contained within these authority records or what are called authority sources. And these authority sources can have authority files. Linked data is structured information contained in a database or data set that allows resource descriptive framework, also known as RDF, which is the structured standard model for sharing data on the web, and also the de facto standard for linked data. Put more simply, RDF is a structured way to represent information about resources. Here's an example. To use it in practice, it might be obvious that Cookie Monster's favorite food is a small round baked good. However, cookies can also refer to the blocks of data that are created when browsing a website. Since you do not want the computer to think that Cookie Monster likes eating blocks of data, you might need to uniquely identify each entity. Now we see the Uniform Resource Identifier, or URI, a unique persistent string that consistently represents a distinct person, place, thing, or piece of information. By using a URI to refer to the same entity in multiple triples and multiple data sets, clusters of data can be connected to one another. Computers are the ultimate literalists, and that's what we have to be real about here. Words are strings, but the same string can mean different things. Next slide. So when we link these authority sources as information architects do and authority files, the authority file is the object that describes the actual thing, which is Cookie Monster in this case. If you link to the Library of Congress authority file service, you will find the URI, which for machines handles variants to resolve entities and define Cookie Monster more explicitly. This is a much more efficient way to communicate with machines. We now know that Cookie Monster is a fictitious character. He also goes by Alistair Cookie. And the Wikidata record is closely related, but not an exact match. Another authority file within the HTTP endpoint to describe Cookie Monster. This is the basis for knowledge graphs and libraries. So both the same, knowledge graphs and libraries. And you take most library catalogs, they in fact are knowledge graphs and can be used as RAG. So the same principles, same layering of structures, same prioritization of machines and human cognition between libraries and the web. And this is true for knowledge graphs. Presenting these things in a structured way so that there's not confusion as to who Cookie Monster is, with the understanding that Cookie Monster's place in the world by way of relationships to other things in the universe. Library science devised this system to help users and machines consistently find information. Next slide. Wikidata brings library classification of digital objects into the internal commons. So we're still working with Cookie Monster, but we go to Wikidata and we can actually play, touch, and feel knowledge graph, which helps to drive systems, but also has been elemental for training data for LLMs. The systems are interoperable, which is a huge win. All too often, I work with engineers excited about linked data and knowledge graphs. These people are quick to jump to using Wikipedia as a source of truth for lack of an ontology, and this is not wrong. However, Wikipedia is not the source file or authority file. Wikidata is the authority source for Wikipedia, and information quality governance with checks and balances, and most importantly, tons of authority files within. If present day AI is about the discovery of information, structured data is instrumental. Training data, such as using Wikidata and Wikipedia, are so important as inputs to AI because of structured data. These taxonomies and ontologies shape how large language models assemble information to allow for meaningful input. Next slide. So we can see that we can ask ChatGPT a very simple prompt to create a Sparkle query for Wikidata to find out more about Cookie Monster. And this is a way to tangibly play with knowledge graphs to understand how information is structured to benefit and to help with retrieval augmented generation, for example, with AI, but it also is essential training data. So this is part of the foundational training data for AI as well. So when we ask ChatGPT how to create the Sparkle query, you can, for Cookie Monster specifically, it will generate it and even pull the exact identifiers from the Wikidata knowledge graph. Next slide. With an authority source are authority files, as we reviewed. So we can see in this record from Wikidata the linked files within. These are the authority files linked within to help to further define and substantiate the claim of who Cookie Monster is. Next slide. The definition of Cookie Monster is created, and you can see here with the simple prompt that when we ask who is Cookie Monster, there's a very exacting answer that we can correlate and associate almost directly with the authority files that we find within the knowledge graph. One of the inputs being Wikidata. Next slide. As we bump through different models, this is Mistral, we can see that it answers a little bit more in depth, and that we can also see from this that the variations in answers between the different models show boundaries and clear intention in the structuring and format of the output. Next slide. The differences in the models really have to do with the cognitive embodiment, but also the parameters, obviously, that are set within. You can see that Llama is very short and succinct when asked the exact same question. Next slide. And as we go to Cohere, we can see this more extensive answer that, again, the information is repeated throughout all the models, just the shape and the format of what's presented as the output varies or is different. Next slide. Anthropic's Clyde delivers an organized response, as you can see with the bullet points. So this sort of shaping and formatting really relates to information architecture, or what we might define as front-end information architecture in this case, on how the responses are generated and what information is presented to the user after prompt time. Next slide. A121 has a much more annotated, shorter response, but is more conversational. It really focuses on the highlight of his character, which is his love for cookies. Next slide. So when we really look at this from front end to back end, or full stack information architecture, we're really looking first at how these models train, and that is with intention. So if you want to explore structured data, authority sources, how information is organized for machines and people, which includes taxonomies and ontologies, here are a collection of some authority sources, and this is by no means exhausted. All of these sources on this screen are used for training foundational models, and there are many, many more. they all link to one another, which is what's very fascinating. So this is really an assemblance of interconnected graphs. And when you are thinking of how you design your RAG or implementations or information spaces to help to disambiguate data and information for LLMs, um, we must think of that root, the root of the information, which is data, and that data, how it's interconnected and organized within. The idea is that your LLM should not be wandering the hallways looking for context and meaning. The taxonomies and ontologies that we build, structured as knowledge graphs, can match the intention of AI, which is what's really exciting. And the idea is to shape data statistically and programmatically into information and output. It's a really fun problem space. Delivered to the user or organization with intention gives the right classification structure or hierarchy to follow, much like a roadmap. Next slide. Many of you will ask, well, can we get by with unstructured data? Sure. But, the first thought you should bring to the table is data quality. If you use training data and curation, if you set intention, if you care about how your model or how you present your data, if you care about cost, if you care about efficiency, and most of all, if you care about interoperability, then you will consider data quality as one of the underpinnings and translate that into a benefit of structuring your data is to help to manage data quality. Structured data in the end is really about aboutness of entities, objects, artifacts, and defines things. Structuring linked data with cognitive models, like we've discussed within this presentation, designed specifically for information retrieval tasks, has the added benefit of reconciling and cleaning data as part of the process. Next slide. I think we can all agree that words are hard. And without words, we do not have meaning. Without language, we do not have language models. So when we adopt and adapt to these global library science concepts, such as cognitive modeling, aboutness, and intentional arrangement, we're really helping models train and as a result, deliver more relevant and accurate output. The very act of structuring your data for human and machine consumption is an intentional arrangement. Understanding that LLMs need the aboutness, they need to understand the context and understand the meaning is intentional arrangement of things. And what we are doing essentially is lending not only context and structure, but we're giving an opportunity for the ability to derive meaning at the time of generating a response. So if we desire to extract meaning from AI, then we do want to bring intention to how we arrange our information and data. Next slide. I really like this quote from Aristotle, who is referred to quite a bit on ontological modeling. As philosophy and ontologies come closer together, and the idea of arranging things intentionally. I like how, if we look back at the whole reason and the origin of using ontologies to structure and to catalog human knowledge, we're looking for high intention, sincere effort, and intelligent execution. So the idea is to determine the destiny, which is essentially with something like a RAG implementation or including IA as part of your AI architecture. You're determining your destiny, and you're helping to curate and to care for. You become the steward of your information ecosystem in order to optimize the interaction between humans and machines. Next slide. I couldn't finish my presentation without mentioning this because with all of the hype around AI, it's been a very interesting space for information architects as the goal is ultimately to make information accessible, retrievable and interoperable within ecosystems for the purpose of curating information to become knowledge. So I really look forward to this conference and the symposium and the exchange of ideas. We have some exciting presentations forums and interviews coming up shortly. So stay with us, and I am very excited. Thanks.
Thank you, Jessica. Before we conclude, I just want to share some of the comments we got
Sure.
on the side here. Yay, all those things connected at last. At Jessica, love this concept of full stack IA. Um, I love the use of the term intentional, which is the thing LLMs and AIs lack. Um, yeah, Liz, we're gonna have this a recording session available so you can rewatch on demand. Marianne says Yahoo appreciated the skills of librarians by having them curate their
Yes.
directory. C is for cookie.
Love
Um,
it, Liz.
Hugging Face has data sets available for training LLMs. And Joy Face on that last meme. Um, so, hey, Matt. So originally, and before we close this off, we had spoken about making the format of this an interactive set of workshops. Um, Again, we have workshops tomorrow, so if you have capacity, sign up. But one thing is to talk about these things, which are very conceptual, very heady ideas. Another thing is to put them into practice. Is there anything you want to say about your journey to get hands on and get dirty in the mix of information architecture?
Sure. I mean, I would consider myself a full stack uh, information architect, but I definitely am not great with I wouldn't hang my hat on UI UX. So I'm very interested to learn myself about the front end pieces of information architecture and LLMs, aside from serving up information. So, within my own experience, I have way more experience designing for backend systems and knowledge graphs, as you mentioned in my intro. Thank you. But what I'm finding is that the more that you mirror that I mean I found more success in the models that I've built in mirroring at base how information is organized in the foundational training data. And I really challenge people to think about pulling those threads from the very foundation of LLMs all the way through your entire architecture. Um, at this point, I think uh, it's an interesting concept to sort of match the back end and the front end to some extent. Um, but I think something that we're finding more and more is that pure implementations of AI without packages and um, uh, modules placed throughout are becoming more and more rare. Pure AI that's able to exist absent of RAG or absent of input are I think non-existent. I would stipulate that they're non-existent. Um, yeah.
Before wrapping this up, I'm just going to flash through the last four
Sure.
comments. Karen saying best presentation I've seen, weaving library
Uh,
science through to present day IA. Such a great session. Thanks for explaining this in a way I can understand. With Cookie Monster, I agree that this presentation could be a series. And thanks for the awesome talk,
uh,
Jessica and Joaquim. So we're gonna take a brief
awesome.
intermission. We may take another 2 to 3 minutes to start on, a little bit further on, but we're gonna be coming on in about 5 minutes to 10 minutes with Marianne. So stay tuned.
Yeah. Thanks.